Hello everyone. The next topic in module 4 is file system. So we all know file is a concept where you can store your data. So file is a continuous logical address space. Whatever user data is stored will be logically shown as it's a continuous address, like it is stored continuously. So there are different types of files like data and program files. Data files, it again has different characters like numeric character and binary files. So see, whatever the data is creator needs, like whatever the content creator needs can be stored in files based on the data or program files. And we have many types of files like text files, source files, executable files, media files, video files, audio files, many more. So for every file that is created by user has many attributes to be given. First one is name. For any file or for any content to be identified or to be human, like if there is a content which has to be recognized by human, has to be named. So again, file is also named, and identifier is a unique tag identification given for a file to identify a file through system. And type, which is like which defines the type of a file, like text file, program file, executable file, all those types. And location is a pointer. For every file you have saved, there will be a location pointer given, so that the address of the file, like starting address of the file, is stored in this location. Next one is size, which defines the current size of a file. Protection is like read, write, executable protections given by the file, like given to the file by the creator of that file for users, owners, and groups, etc. Time, date, and user identification is like creation date for protection, security items like security purpose. Then usage of monitoring, how many times the date and time, like modification date and time, so that the date and time has modified can be like you can find the date of modification of the file. And we have directory structure, so that the file information can be stored in some order. So directory structure helps to maintain and order your files. Next one is file operations. So file is an abstract data type, means it has a file is also a data type, and it is an abstract data type. We can have operations like create. Whenever you want a file is newly created, create operation is used. Write operation at write pointer location, where the pointer is presently located. From there you can write onto the file. Read is for reading the file, and read pointer is used. Next one is repositioning with the file, and repositioning with the file we use pointer called seek. Delete is used for deleting the file. Transcat and open fi, close fi is for searching a file directory structure on the disk based on fi, like fi is a pointer from the directory structure, so that you can move the content of entry to memory, like based on fi pointer. Opening of a file and moving the content can be done. And close fi is like a fi is a pointer and directory structure on the disk which can be closed, like open file fi can be moved from that directory to the on the disk to the main memory based on fi, open fi pointer. And close fi, again we can use fi pointer to move the file from main memory to disk. Next one is open file. So open file, we to open a file there are many constraints that a system has to follow, or operating system has to follow. First one is open file table. So open file table is a maintenance table kept for tracking of all the open files. So this table will have all the like names, list of files which are opened at present and the pointers for this. And file pointer to last read or write location on the process. Instead of keeping a pointer, like open file table will have address pointer, what are the files open, and like a list of files and the pointer for the location. In that, file pointer will be the pointer where you have stopped reading or writing previously. For that location, the pointer, this file pointer will be pointing at present. Next one is open file counts. It will give you the count, how many number of times the file has opened. So here in open file table there are list of files, and this file open count will give the count how many times this open files, like list of files, are opened. Like if you are using a file called file1 and you are opening it for 2 times, means the count of the file will be, open file count will be increased. If you open it again, which is already there, then the count will increase. To manage which file to remove from main memory when it comes for page replacement. Next one is disk allocation of the file. It's like caching the data access information. So if you have a disk location of file, once you get, if it is contiguous allocation, the first pointer, like the pointer address of the file, like first address is fine. If it is non-contiguous, then first pointer will have, means if it is linked list, it can go for next. So disk location of the file is important for opening and accessing the files. Next one is access rights. So read, write, execute as per the user's need, access rights are given to that files. So that access rights information is also important for opening a file. Next one is open file locking. In open file locking, again we have read, write, lock. Who can read the file, who can write into the file, that is one read, write, lock. Next one is shared lock. Similar to read lock, several processes can acquire concurrently. Shared lock is like if you have a reader writer problem, then we have used shared lock for writing and reading purpose. Next one is exclusive lock, similar to write lock. See, in shared lock, it's like reader lock. Many number of process can read unless one writer is acquiring the file. So exclusive lock, exclusively given for writer. Once writer is writing the data, then readers are not allowed. No readers and writers is allowed. Shared lock means many number of process can open that file for reading. And writer lock, once writer has acquired, no process is given with reading option also and writing also. Next one is mandatory and advisory. So in mandatory, access is denied depending on locks held and requested. In advisory, process can find the status of locks and decide what to do. So here we have some different like file types, what is its extension and functions. So we all know we have executable files, extension is exe, .com, bin and all, where the files can be executed, and it is like machine level language files. Object files, compiled and machine level language files, which can be with the extension of obj and o. Source files like our all program files, which is having source code, and batch files, which like commands to command interpreters. Text files like our notepad, documents, etc. Word processors, again are text files. Library files, print or view files, it may be like image files. Archive, like our zip files, where you can archive different files. Related files can be grouped as one file. Sometimes it can be minimizing the size also. Zip can even minimize size also. Next one is multimedia files, like our what to tell, mp3, mp4, audio and video files are considered as multimedia files. These are some different types of files we have. So next one is a file structure. Non-sequence of words and bytes. File structure, if you are storing the data in the disk, it is not sequentially stored. So simple record structure may have lines, fixed length and variable length. So file can be stored based on how your disk is managed. It may be like files can be stored based on lines or fixed length, like file can be divided into fixed length of blocks, or files are divided into variable lengths based on how your disk is managed by the operating system. Complex structure is like formatted document and relocatable load files. Formatted documents, relocatable data files are like a structure of files where operating system decides how to store them, how to relocate them. So these relocatable load files are the files for compiler, like compiling and load files. So these are like complex structures, and which is also managed, like who decides how to store them, or simple records, complex structures, how they are decided to store and maintained as operating system. So operating system decides how to store, how to maintain them, let it be simple records or it is complex structures, based on operating system and the programs or the device drivers which is responsible for disk management is will decide how to store, how to structure the files. Next one is access method. So here in access method we have three different types. One is sequential access method. Sequential access method is very simple. So let's consider this as a file, beginning and end of a file, and this is the current position. So read next will go for reading next document, means next part of the process. Write next in the current position, write next will go right in this order. Reset, no read write lost. See here, reset in the sense if you reset it will come in this current position, will come to the beginning. And rewind is used for going back. Next one is direct access. Here instead of next we have a pointer called n. Read n wherever the current position is. If you give n means the logical address, like give the address pointer, go to that pointer address from the beginning to end. Somewhere in between there is a address block called n. Read n will start reading the file from the nth location. Write n is same thing. Whenever you pass a command n, so write n will start at the nth location in that file. Position to n means the current position will go to the nth position. And read next, write next can be used. Since you have current position, you can also use read next from the current position, start reading next, start reading n, and rewrite nth position. If the data is already written in nth position, you can rewrite. So n is relative block number in this file. So the file begins from 0th address to 1000 address. Nth address will be in between this beginning and end. So n will be relative block number. So relative block number allows OS to decide where file should be placed. So simulation, sequence of access on direct and access files. See here, sequential access file and direct access file. So in sequential access file, it only uses next pointer, means it goes sequentially. In direct access method, you can access directly by giving the relative address. So in sequence access, for reset, to go for beginning address, means to set the pointer current position to beginning, then we use reset. In direct access method, we use cp equal to 0. Read next, for reading the next value, read cp will read the value cp plus 1. So cp is the current position. From current position you can read the next position. Write next, same thing, write cp. cp is used for current position, so current position plus 1. This is an example of index and relative files. See here, in the index file, logical record number will be there for the last name. So last name of a file is stored in the index file, and logical address number means record number will be there in the relative files. Relative files will have complete data and based on the last name, the index file can fetch the relative file of that document. So relative file can be fetched through index. In the index we have last name and logical address number, record number, which is pointing to the relative file in the main memory. Thank you.